And welcome back to Backspace Academy. In this lecture on databases on AWS, we're going to build on what we've already known with RDS, and then we'll move on to some of the other database services. So we'll start off by looking at the backup options that are available for RDS, and then we'll move on to looking at the multi-availability zone feature of RDS, which enables us to have high availability in our architecture. Then we'll move on to the DynamoDB NoSQL as a service. And then we'll look at Neptune, which is a graph database as a service. We'll look at the big data Redshift, which is a data warehouse for petabytes of data. And again, as a service on AWS. And finally, we'll look at Elasticache, which provides high-speed access to our data through an in-memory cache. Okay, so we already know what Amazon RDS is. We've already launched the MySQL instance and we've connected to that instance via the RDS endpoint. So we know that it runs MySQL. We know that it runs variations of MySQL. It runs MariaDB. It also runs Amazon's enterprise version of MySQL, which is Amazon Aurora. It also runs PostgreSQL. It runs Oracle, and it also runs Microsoft SQL Server. And it also runs PostgreSQL, also on Amazon Aurora. It's a container service. So what that means is it handles the routine database tasks such as provisioning, patching, backup, recovery, failure detection, and repair. So Amazon, in their shared responsibility model, are taking more responsibility for the running and security of the RDS service. There are two options available for us for backing up our data in an RDS instance or in an RDS database. The first one being is user-initiated DB snapshots, and that involves us going into the console and manually creating a snapshot of that instance, or we can do that through the command line interface as well. Or if we would like to, we can also automate that process through automated DB backups over to S3. The way that works is that when you go to create your RDS instance in the console, there will be an option there where you can specify the time period for automated backups. And if you specify 0, then you won't have automated backups. If you have your database encrypted, you can also have your snapshots at rest encrypted as well. Now, we never use the multi-AZ feature of RDS because it's not available on the free tier. But you still need to know why to use it, and it is recommended for all production applications. And not only should your database be multi-AZ, but your application itself that's running on EC2 instances should also be in a multi-AZ environment, because it's no point your database going when an availability zone goes down if your application itself is not continuing to operate. It's available for all database engine types, and it allows for very rapid failover to a standby instance. So the way it works is, here we have a highly available architecture, and we've already done that. We've already done that in Elastic Beanstalk, where Elastic Beanstalk put multiple instances in an auto-scaling group and spread those across multiple availability zones for us. And it also established an Elastic Load Balancer, which would take traffic and distribute that traffic through to those instances. And those instances can connect to our database endpoint. Now, we already know about database endpoints because we've manually connected into those through our desktop computer. So our instances will connect in to that database endpoint. And then the Route 53 service will manage that domain name there, or that endpoint, and it will direct traffic, point traffic to our RDS DB instance. And at the same time, we have a standby instance in another availability zone. And that is asynchronously replicated from the master database. So effectively, we have two copies or two databases that are identical running in two separate availability zones. Now, if, for example, an availability zone goes down or a database goes down, so this master database goes down and we've still got traffic going to it. So if we've got multi-AZ set up, then what will happen is that the Route 53 service will then point the endpoint to the standby instance. And so you can see here, so all of a sudden, our endpoint is now pointing to our standby instance. And our EC2 instances do not really get affected at all. So this happens very, very quickly, virtually instantaneously with DNS changeover like this. Now, another thing that happens at the same time is that our previous standby instance gets promoted to becoming the master database. And when our failed instance in the other availability zone, when that comes back up and is back online, that will become the standby database, and then replication will occur from the new master database over to that new standby database. DynamoDB, it's Amazon's NoSQL database as a service. It consists of tables. For example, if you had people or persons, you could have a table for those people. And those tables are made up of attributes. For example, people would have a first name, a last name, an email address, a website, for example. And our tables contain items, and they are records of those persons, for example. So that would contain items of those individual people. So looking down there at the bottom, we've got a people table, and we've got an item there of Bill Smith. So there we've got his first name, Bill, his last name, Smith. The second item there in the table is for Joe Bloggs, and he's got first name there, Joe, and last name, Bloggs. Now, if we need to quickly search on that data or query that data, we need to set up a partition key and an optional sort key. And that has to occur when you create your database table. What that allows is that you can very quickly search on that partition key. So for example, if our partition key was last name, we could search on that. For example, we could search for Bill Smith very quickly on his last name. And we can also have an optional sort key, which will also speed up that process of querying that data. We may find that if we've got a very complex table that has lots and lots of attributes, that we still need to have other attributes to query upon, and it's not going to be efficient for us to do that. And that's where DynamoDB secondary indexes come into play. And they allow for efficient access to data with attributes other than the primary key that we've defined when we created our table. There are two types of secondary index. There's a local secondary index that has the same partition key as the base table, but it has a different sort key. And we have a global secondary index that uses a partition key and sort key that is different or can be different from those on the base table. So for example, here we've got our people table again, and we might have a primary partition key set up for last name and a sort key, primary sort key set up for first name. But we might also want to be able to search based upon or query based upon email. So we could set up a local secondary index that uses the partition key last name, and then it has a sort key of email. Or we could also, if we wanted to sort or query based upon email and website, we could set up a global secondary index that would have as its partition key an email, and as its sort key would be website. And that allows for very efficient and fast access to your data based on what you are looking for. Amazon Neptune is AWS's graph database as a service. A graph database, it differs from a relational database and it differs from a NoSQL database. It is purpose-built to store and navigate relationships. It's focused on relationships, even more so than a relational database. Now, if you want to learn a lot more about graph databases, I think the best place to go is to go to icij.org. And that is the website for the International Consortium of Investigative Journalists. And what they did is that they analysed the Panama Papers and the Paradise Papers when they got those leaks, and they used Neo4j, which is another graph database. They didn't use Neptune, but they used a graph database to go through literally terabytes of data and establish relationships for each piece of that data. And then once they went through that data, they were able to use Neo4j to navigate through that quite quickly and very quickly establish links between, or relationships between, heads of state and money laundering operations. And without a graph database, it would have been so much more difficult. It would have been very difficult with a relational database, and it would have been near impossible with a NoSQL database. It would have been a lot more difficult. So a graph database, it uses graph structures which consist of nodes and their data entities. On the diagram here we can see Jack and Mac and Harry, they're nodes. And we have edges, and they're the relationships between nodes. So we can see there's a relationship between Jack and Mac. There's also a relationship there between Jack and Doug. And we also have properties for nodes. And so that is data that we can associate with that node. We can query this using the graph query languages Gremlin and SparkQL. Amazon Redshift, it is a fully managed big data. It is petabyte scale, big data warehouse service provided by Amazon. It is based upon PostgreSQL, and it's specifically designed for online analytics processing and business intelligence applications, which require complex queries against very large data sets. So we're talking about petabyte scale stuff here. It's pure big data. A Redshift cluster, it consists of a set of nodes, and one of those nodes will be a leader node, and the other nodes will be compute nodes. We have a choice of type and size for those nodes as well, in a similar way that we have for Amazon EC2. Finally, I'm going to talk about Elasticache, and that is our fully managed in-memory data store service. What that allows us to do is that it can grab our popular content in our database, and it can store it and have it accessed from memory. And that provides really low latency, high speed access to that data. There are two options for that engine. There is Redis or Memcached. They are both open source engines, and they don't require a license as such. So let's have a look over here. So if we have a DynamoDB database that contains our data, maybe 5% of that data might be accessed very regularly. It's popular content. So we could set up a Lambda function that could copy the regular content, the popular content, over to Elasticache. And then when our EC2 instance that has our application on it wants to get data, it can look for it in the Elasticache. And if it's there, it will be delivered back to that EC2 instance very, very quickly. If it's not there, then the EC2 instance will go to the main DynamoDB database and get it. And so that way, we're really providing a much higher speed access to that data, and we're also reducing the load on our database itself. We're not stressing out DynamoDB and incurring costs because of that. So let's have a look at an example here. So we may have an internet scale application. That could be a very popular online game. And so that online game might have hundreds of thousands of users. And those users all have a user profile data, and they access their own user profile data. But also there might be a gaming leaderboard, and that is accessed by everyone. And that's very popular. Everyone wants to see who is on the leaderboard. So that gaming leaderboard could be copied over to Amazon Elasticache, and that will provide really high-speed access to that gaming leaderboard for our application. And then our user profile data, which is not accessed as regularly, could be accessed directly to our database itself. So that's it for databases on AWS, and I look forward to seeing you in the next lecture.